In today's lesson, we are going to discuss scientific notation. In order to work effectively with scientific notation, you must know the rules of exponents. If you do not know the rules of exponents, you need to review tape 102 before doing tape 103. As you go through the tape, if you have questions, be sure to stop the tape and get someone to help you. Let's start by looking at an example. We have 280,000 times 12 million. Let's try to do that example on our calculators, assuming it still works. So let's take the calculator and let's multiply the first number. So it'd be 28 with 4 zeros, 280,000 times the 12 million. And 6 zeros. 1, 2, 3, 4, 5, 6, and hit equals. Well, that's kind of a weird display. What does it mean? 3.36 with a lot of spaces and 12. Try it on your calculator. See what your calculator would do if you multiply 280,000 times 12 million. Well, the calculator that you've just seen gave this. 3.36, left some spaces, and gave 12. What does that mean? Someone else's calculator may give 3.36 with a little e and then 12. Both of these calculators, or both type displays, are giving the answer in scientific notation. Both mean 3.36 times 10 to the 12th. 3.36 times 10 to the 12th is the correct scientific notation. Now let's look at the formal definition of scientific notation. A number written in the form n times 10 raised to the e power, where the absolute value of n is between 1 and 10. It could equal 1, but it cannot equal 10. And e is an integer, is in scientific notation. So scientific notation is of the form n times 10 to the e. N is some number, the absolute value of n is some number between 1 and 10. It can be 1, it can't be 10. In other words, n has one digit to the left of the decimal place. So 1 is a number that has one digit to the left of the decimal place. E is any integer. Now your integers are numbers like 0, 1, 2, 3, 4, 5, 6, and so forth, and -1, -2, -3, -4, -5, -6. So that's what I mean by scientific notation. Let's look at some examples. 2.3 times 10 to the -18 is in scientific notation. 2.3 has only one decimal to the one digit to the left of the decimal. -18 is an integer. So 2.3 times 10 to the -18 is in scientific notation. Another example, 5 times 10 squared. 5 times 10 to the 23, 5 times 10 to the 23rd power. We have an understood decimal here, so I have one digit to the left of the decimal. 23 is an integer. So 5 times 10 to the 23rd is in scientific notation. A -7.1 times 10 to the -19 is in scientific notation. We have one digit to the left of the decimal. -19 is an integer. Now, in order to help you understand what scientific notation is, let's look at some things that are not in scientific notation. 38 is not in scientific notation. We're not multiplying it by a power of 10. 280 times 10 to the 5th looks like it's scientific notation, but you have 3 digits to the left of the decimal place rather than only 1. See, the decimal's understood to go behind the 0, so we have 3 digits to the left of the decimal place. So it's not in scientific notation. 0.12 times 10 to the negative 6 is not in scientific notation because I do not have a non-zero digit to the left of the decimal place. There are no non-zero digits to the left of the decimal place, so it's not in scientific notation. Numbers in scientific notation can be converted to decimal notation by performing the operations. So one thing, if your calculator gives you the number automatically in scientific notation, you can easily convert it to decimal notation by performing the operations. Look at some examples. Let's look at 2.8 times 10 cubed. Well, according to the rule for the order of operations, I raise powers to powers, or I do exponents before I do multiplication. I do exponents before multiplying. So to do the exponents, I would do 10 times 10 times 10. Well, 10 times 10 times 10 is 1,000. So 2.8 times 10 cubed is the same as 2.8 times 1,000. Now I do the multiplying. 2.8 times 1,000 is 2,800. Let me multiply that and show you why. I'm multiplying 2.8, I'm multiplying it by 1,000. So bring down the zeros. 1 times 8 is 8, 1 times 2 is 2. Mark off one decimal place because 2.8 has one place, and you're left with 2,800.0, which is the same as 2,800 or 2,800. So 2.8 times 10 to the third power is the same as 2,800. Let's look at another example. Let's look at 1.3 times 10 to the negative 3. 1.3 times 10 to the negative 3. Now recall that a negative exponent tells you to take the reciprocal of the base. So I would get 1.3 times 1 over 10 cubed. Now that would be the same as 1.3 times 1 over 1,000, because 10 cubed is 10 times 10 times 10, which is 1,000. I can rewrite 1 over 1,000 as the decimal 1,000th, 0.001, because see, this would be now tenths, hundredths, thousandths, so that's 1,000th. So I have 1.3 times 1,000th. And then if I multiply it, I get 0.0013. Again, I'm going to multiply that and show you. We've got 1.3 times 1,000th. Well, 1 times 3 is 3, 1 times 1 is 1. Excuse me. I have to mark off 1, 2, 3, 4 places. 1, 2, 3, 4 places. So I get 0.0013 or 13/10,000. Now notice what's happened with these. When I did 2.8 times 10 cubed, I really just moved my decimal 3 places to the right. Notice if I put the 2.8 down, I move my decimal 1, put the 0 so I can move it 2 more, I move my decimal 3 places over, I get the 2,800. When I did 1.3 times 10 to the negative third, I moved my decimal 3 places to the left. Put down to 1.3 and move the decimal 3 places to the left, and you get the answer. So in essence, the exponent tells me the number of times to move the decimal. Positive exponent, move the decimal to the right. Negative exponent, move the decimal to the left. And that's how you can change from scientific notation back to decimal notation. So if you're using a calculator or a computer that automatically gives you scientific notation, always convert it.